All right. So here's my, bless you, here's my first disclaimer. The first three problems on the review are what I would consider multiple choice, even though there are only two choices in your multiple choice. My disclaimer is just because the first problem on this particular review asks you what kind of data gender is, that doesn't necessarily mean that the exam that you take or the review that you do, they're going to ask you for qualitative data. For example, here is the review that I have open in my open math. And I did get a similar question a couple of times. And the first question in this review now says, in a study, the data you collect is weight in pounds. So it's important you understand what is the distinction between qualitative data and quantitative data. Qualitative data is a quality. Quantitative data is a number. So if I measure weight, that would be quantitative. If I look at gender, that would be qualitative. So be sure you read the problem and determine, is it something you're measuring or counting? If it's something you're measuring or counting, it's quantitative data. If it's a quality you're looking at, let's get another similar question. In a study, the data you collect is gender. So we're back to the gender question. So gender is qualitative, correct? So be sure you read the problem. That's my disclaimer of the day. You read the problem and make sure if it's numerical, quantitative, if it's a quality, it's qualitative. An attribute, it's qualitative. Okay, let me go back to my notes. Okay, so in my first question here, in a study, the data you collect is gender. We decided that was, or I decided that's qualitative. And did everybody, I guess everybody got a copy of the review? All right, so the next question is the same disclaimer. So just because this particular data is what? What is it? The number of children a person has. Is that discrete or continuous? It's discrete because you count it. Now, again, real quick, going back to the review, doing the similar question a couple of times, the second question is the average weight. Well, that's something you measure, correct? So weight would be continuous, not discrete. So just be sure you read the question and you understand the difference between qualitative, quantitative, discrete, and continuous quantitative data. All right. The third question, does this describe an observational study or an experiment? What kind of study is this? The temperature on randomly selected days throughout the year were measured. Why is it observational? Yeah, you're not setting up an experiment to collect data. You're just observing what the temperature is. So that's observational data. Okay, question number 4. In a study, the sample is chosen by asking our 40 closest friends. So what is the sampling method? What's that? Why is it convenience? Yeah, it's just convenient. Now, again, is the same question going to be convenience sampling on question 4 on your review? I don't know. Let's go over there and see. Let's get a similar question. A sample is chosen by choosing every 5th person. What's that? systematic. So be sure you understand the different sampling methods and how they're conducted. I think you got it. All right, so finally we get to a question where we actually have to do something. So I have a data set and I'm going to create a stem and leaf plot from this data. Now, I'm going to provide you with paper that you can write on. If you prefer to use paper with lines on it, you're going to have to bring your own. I'm going to provide you with printer paper. But if it were me, and it was, I did this, to do this problem, I would just go through the data and find all the 50s. So the first stem we have is 5. So that's all the data that has a 50, 51 or 50 or whatever. 50 through 59, I can talk. So I'm just going to go through and find these, and I'm going to write them down. Make sure I find all of them. Did I find all of them? Nope, there's 154 right there. Okay, I think I found all the 50s. Would you agree? Looks good. Okay, so now I'm going to put my leaves in order. So I have a 0. I have another 0. What's the next? Do I have 2 2s? And then what do I have? A 4 and a 6 and a 7 and a 9. And they don't want you to put spaces between the numbers. They actually give you instructions down there at the bottom. No spaces, no commas. However, if you put spaces or commas inadvertently, I will grade it and make sure that you actually, if you put spaces, the numbers are correct. All right, so I got all my 50s. I'm just going to erase this because I have the power to erase. And then I'm going to find all the 60s. So what do we have? 67, 63. And I know this is kind of slow. It would be way easier if the data was sorted. What are we going to do? 66, is that all of them? Okay, so you're in agreement. So what do we got? 3 3s? A 6 and a 7? Okay. You don't have to erase. You got a big old piece of paper you can write this on. Okay, now what are we looking for? The 7s? So I got one there, 71, 73, 73, 72, 78, 73, and 75. Did I get all of them? Just do a quick check to make sure there's no 70s left in there. Okay, so what do I have? A 71, a 72, 2 3 3s, 2 3, a 5 and an 8. And then last but not least, the 80s. So I have an 81, an 84, an 88, 88, 88, which I should be writing these down, 84, 3 88s, 83, another 88. Oops, skipped the 85, didn't I? 85, an 80, lots of 80s. Is that it? You see any other that I haven't circled? 83, thank you. Okay. So I got a 0. I think that's an 83. An 81. 2 3s. 4 5. And then 4/8. Tedious, but not particularly difficult. All right. As a matter of fact, a lot of these problems are just like the next one. What's the 5-number summary? So do we just go across? Start at 7 is the first number, 11's the first quartile, the median is 13, the third quartile is 15, and the maximum is 19. It's a pretty easy test. All right. Now this one, again, your spinner may be different than my spinner. It may only have like 10 numbers on it or something, but just be aware that your spinner may not be the same as mine. Use the spinner below. Find the probability of a 10 or a 12. So what is your probability rule for an OR type probability? Is that the probability of A plus the probability of B minus the probability of A and B? Now, the probability of A and B is 0. Why is it 0? Because can you get a 10 or a 12 at the same time? If you flick that spinner, you're going to get a 10 or you're going to get a 12. You're not going to get both at the same time. We're not going to have any spinner landing on a line thing. Okay, so these are mutually exclusive. They can't occur at the same time. So since they're mutually exclusive, the and probability is 0. So the probability of getting a 10 or a 12 is just the probability of getting a 10 plus the probability of getting a 12. What's the probability of getting a 10 if you flick that spinner? 1 over 12. There's only one 10 out of 12 possibilities. So is that 1 over 12? What's the probability of getting a 12 flicking that arrow? 1 out of 12. Only 1 12 out of the 12 spots, right? So what is that? 2 over 12, which is, and they do they say reduced fractions? They don't. So just read the instructions. If they don't say reduced fractions, they should accept the unreduced fraction, but can your calculator reduce a fraction for you? Yes, it can. All right, so now what are we doing? Suppose you roll a special 12-sided die. What's the probability that the number rolled is a 1 or a 2? Two over 12. Who said that? Very good. These are also mutually exclusive, correct? You can't get a 1 and a 2 at the same time. So this is just the probability of getting a 1 plus the probability of getting a 2. It's a 12-sided die. So that's 1 out of 12 plus 1 out of 12, which is again, what, 1 over 6? And again, they don't specify reduced fractions. So. All right. Now, I'm not sure, I didn't do a similar question on this one. I should go and do a similar question after we answer this. What kind of distribution is this? It's uniform. It's not bell-shaped. It's not skewed one way or the other. It's pretty flat, which is a uniform distribution. And then it asks the question, then what measure of the center of your data should you use? If it's not skewed one way or the other, you're going to use the mean, okay? Because where you would use the median if you have skewed data one way or the other. If you have skewed data, then you've got extreme values that affect the shape of your distribution. If it's a normal distribution, kind of that bell-shaped thing, or it's uniform, just use the mean. Otherwise, you might use the median, but for a uniform or a bell-shaped distribution, you would want to use the mean. So let me run over here real quick. Let's do a similar question on that one, see what it does. See, it's skewed. Is it skewed left or skewed right? Is it skewed left? So I would probably use the median since it's skewed, wouldn't you? Because the reason you wouldn't want to use the mean is because those extreme values affect the mean, because the mean uses every data value to calculate it. The median is just the middle. So if you have skewed data, you probably want to use the median and not the mean. Okie dokie, artichokes. All right, a bag of M&Ms has 6. So far, this has not been a difficult test. Would you agree? Now, the other thing is that the questions can be jumbled from the review. So the first question on the review may not be the first question you see on your exam. A bag of M&Ms has 6 red, 5 green, 7 blue, and 4 yellow M&Ms. What's the probability of randomly picking a yellow? Four over 22. Do I have 4 red out of the 22 total? So someone that added that up for me. Thank you. That there are 22 total M&Ms in this bag, and we're not eating them until we finish the experiment. All right, so I do need to reduce this. So there is a common factor of 2 in 4 and 22. So can I cancel a 2? Okay, 2 over 11. What is the probability of getting a blue or a green? Yeah, I would just count. How many blues do I have? 7. How many greens do I have? So is that 12? It's the probability. It would technically be what? 7 over 12 plus 5 over 12? 22. You didn't see that? Just right over that. So what is that? 6 over 11? And then an orange. There ain't no orange M&Ms in that bag, so the probability of getting an orange M&M is 0. All right, a couple of contingency tables. Using the contingency table to find a, why is this word just escaping my brain? What's Bayes' theorem? Somebody find the C word for me. It's like the last 3 days. Can't think of that word. Anyway, giving a test to a group of students. The grades and gender are summarized below. If one student is chosen at random, find the probability that student was male and got an A. So 4 males got an A. That is what the intersection of that column and row gives me. It gives me the and value. So the number that are male and got an A is 4. But what's the probability of being male and getting an A? Is it 4 over 73? So 4 of these students were male and got an A out of the 73. Siri thinks I'm asking it how to find 4 over 73. All right. Giving a test to a group of students, the grades and gender are summarized below. If one student is chosen at random, find the probability the student got a C given they were male. You could use Bayes' theorem on this. Got a C given they were male. That's the probability that they, oh, my app is trying to help me. The probability that they got a C and they were male divided by the probability that they were male. And again, these type of probabilities, the given probabilities, they reduce your sample space. So they reduce it to the number of males you have. So what is the number of males that got a C? Is that the 19? Male and C over the number of males you have. How many males do you have in this study? 37? So the probability that you get a C given you are male is 19 out of 37. All right, another simple probability. Suppose a jar contains 12 red marbles and 15 blue marbles. If you reach in the jar and pull out two marbles at random at the same time, find the probability that both are red. So this is the probability that the first one is red and the second is red.
And you're pulling in them at the same time, so there's no replacements. You have to factor that.
Very good. So you're pulling them out at the same time, so you're not replacing the marble before you pull the second one out. So the second draw is dependent on the first draw. So it's going to change the number of marbles in the bag. It's also going to change the number of red ones in the bag. So what's the probability the first one is red? Oh, by the way, if it's and, we are going to multiply. If it's an or, we add. If it's an and, we multiply. So what's the probability the first marble out of the bag is a red one? How many do we have total? 27 total? So what's the probability the first one is red? Is there 12 out of the 27 are red? But now you don't have 27 marbles in the bag anymore. How many marbles do you have in the bag? 11. I got it. 11 out of 26. So still in the bag are 11 red marbles, and there are 26 marbles in the bag total. So what's 11 times 12 divided by 27 times 26? I get 0.1880, rounded to 4 decimal places. And I suppose it would be okay to write this as a reduced fraction. So 22 over whatever 13 times 9 is. I suppose you could do that. Pardon? It doesn't specify one way or the other. And believe you me, if you put a fraction in your answer field and it counts it wrong, I take my calculator out and I calculate your fraction to make sure they're not counting it wrong because you put a fraction in instead of a decimal. I check all of that. And this app is really nice, this my Open Math, because I can grade one problem at a time. So I can grade everybody's first problem at the same time. It's great. It's great. Great. All right. Creating a frequency table. The following data set outlines the scores students had on an algebra test. Let's create a frequency table. So the scores that I have that are unique to this set of data are 40, 41, 42, 43, 44, and 45. And now I'm going to determine the frequency of each of those scores. So how many 40s do I have? At least this data is in order. Do I have 4? How many 41s do I have? 1. How many 42s do I have? 2. How many 43s do I have? Just 1. And 44, do I have 3 of those? And 45, do I have 1 of those? So there is my frequency table, and they're going to want you to create a scatter plot, a dot plot of this data. And the dot plot's actually fairly easy to do in my open math. I'm batting 1,000. I did this review the other day, and did I get the box plot correct? I did not. So I'm batting 1,000 there. And I did grade that homework problem. I don't know if you noticed it, but if you got the box plot correctly on this particular problem in the 2327 homework, I gave you credit, double credit. Everybody else just got credit for it. All right. So let's see if I can do this. 44. So score of 40, there were 4 of those. 41, there was 1 of those. 42, there were 2 of those. 43, there was 1 of those. 44, there were 3. Is that correct? Does that look good to you? No, you do not. Just plot the dots. You have a little pencil tool with a dot and you just stick the dot on there. And it even gives you partial credit. If you get 5 of the 6 dots correct, it'll give you credit for that. Okay. Oh, everybody's favorite problem. Now, actually, the first part of this is plunking it into your calculator and letting your calculator do the calculation for you. It's just that pesky box plot. And again, if you want to attempt it, maybe wait till the end and go back and attempt it, because you can get extra credit for getting it correct. So go ahead and give it a try. I'll grade it. If it looks like you're all correct, I will give you the double credit, even though my open math counted it wrong. If you just leave it blank, I'll give you credit for it anyway. There's no loss on your part for not trying it. Okay. So I'm going to put this data in my calculator. So I'm going to go over here. I'm going to share my screen so we can see my calculator. There we go. Okay, so I am going to put this data in a list. And I don't know if I have stuff in my list. Oh gosh, my lists are completely full. So I'm just going to go clear them all out at once. Get rid of everything. So I'm going to get out of my list and I'm going to go to my memory, which is above the plus sign on my calculator. And I'm going to clear all my lists out. So I'm going to do a number 4. So click on the 4 and then enter. And now my lists are all clear. So I can start fresh. So I'm going to go back to my lists. And I'm going to put this in L1. All right, so I have 35. And when I do this, I am going to go back and check, not that I put in data incorrectly, but I put data in incorrectly. So I need a minus sign. The other problem with the box plot for those of you who attempted it. Oops, that's not gonna work. The scale on the horizontal scale is not precise enough for you to put like a negative 2.9 in there. So it gets very difficult.
So any version of this question on the test that does not involve negatives?
I don't know. We could go do I would venture to say no, but we can go do a similar question and see. Does anybody have their review up? Does it give you negatives in your data set? I would guess that they all have a negative in it, at least one. And as long as I'm not worried about the box plot, I don't care if the data is negative or not. I mean, my calculator can certainly find the mean and the quartiles for me, no matter what my data set is. Is anyone planning to use Excel for any reason? The next chapter you might want to, the next module, because we actually do a probability distribution that your calculator doesn't have on it. Okay, Lisa, stop talking and get your data in. Okay, I'm going to do a quick check. So I'm going to go back to the top. $35.5, 7.9, 26.5, negative 2.9, negative 0.7, 14.9, 34.7, 19.3, 15.5, 25.1, 21.8. And this is actually fairly important for you to do as you're taking the exam, because I cannot see your calculators. I do not know what you entered. So just be sure you do a quick check. Okay, 21.8, 25.3, 36.9, 29.4. Okay, I looked at, I think, I hope. All right, so once I have my data in, I'm just going to calculate all the one variable statistics. So I'm going to get out of here, second quit, go back into my stat menu, arrow to the right to my calculate menu, and I'm going to calculate the one variable statistics on my L1 list. So I'm going to change that to L1, second one. I don't have a frequency table, so I don't have any frequencies. So I'm going to leave that blank and then calculate. So my mean, oh, I must have something incorrect. I got 22. What did you get for the mean? 22.27. Maybe I wrote it down wrong. On my paper, I wrote down 21.85.
We gotta check.
So I either put something in incorrectly. 21.85 looks to be the answer. What's the median? Okay, I got to go back and.
Okay, so I didn't.
That's what I have on my card.
What I had?
Yeah. But I.
Um. I put something in incorrect. Well, it's like, do we take a Democratic vote if the majority of us got the same answer? Then we're okay. I don't know if that works that way. All right, let me check real quick. Now I'm doing this without glasses on too. Well, the method I'm using is correct. So I'm going to find the one variable statistics on that data. On my paper, I have 21.85. Up there, it's 22.2667. And I can't see where I can't see where I made the error. All right, we're gonna go with it. Okay, the standard deviation, they want you to input. Well, let's go to the median first. What's the median? The median is 25.15. The standard deviation, the one they want you to put in is the S sub X, which would be, how many decimal places? They said 1 or 2. So would be 12.41.
Yeah, I forgot about that.
The minimum value is the negative 2.9. The maximum value, I'm going to scroll down. The max is the 39.6. The range, then I have to actually calculate this. So I take 39.6 and I subtract negative 2.9. So what's that going to be? 5 at 42.5. The first quartile is the 14.9. The third quartile is the 33.4. So what's the interquartile range? The 33.4 minus the 14.9. Interquartile range is Q3 minus Q1. And then the last part of this problem is the box plot. And like I said, I'm batting 1,000. I've never got it correct. I tried real, I tried to be sophisticated this time and drew the vertical lines, for the box first, and and I still didn't get it. So do your best attempt. I will grade it. If it's not even close, you'll get credit. If it's close, I'll double the credit. All right.
For the standard deviation, why is it the S of X sometimes, and then why is it the breach?
Depends on if you're looking at a sample from your population or you're looking at a population. And this is a sample. It's winter temperatures in randomly selected towns and villages in Alaska. So that is a sample of all the temperatures in Alaska. So since it's a sample, you would use S sub X. Sigma would be if this were the entire population, which it is not. You're welcome. All right. Another frequency table. Every year, the students at a school are given a musical aptitude test. So I would be the frequency of 1 with the 0. That rates them from 0, no musical aptitude, to 5, high musical aptitude. This year's results were So in the left-hand column, they give you the aptitude score. And in the right-hand column, they give you the frequency. What is the mean? How would you find that? I'd let the calculator do it. So I would put the aptitude score in one list and the frequency in another, and then find the one variable statistics using the list and the frequency. So let me go back to my calculator. And I'm just going to go ahead and put it in L2 and L3. Might as well leave L1 alone because I still got a mistake in it somewhere, which I need to figure out where it is. All right. So let me go to edit, L2, and I'm going to put the aptitude scores. Is that 0 through 5? And then I'm going to put the number of students that had that aptitude. I had 1 with a 0, 0, and I do need to put that in, 0 with 1, 5 that were 2, 2 that were 3, 3 that were 4, and 4 that were 5. Okay, so the first thing I need to calculate is the mean. So I'm going to exit out of here. And I'm going to go back in my stat menu to calculate the one variable statistics. The aptitude scores I put in L1, L2. So I'm going to change that to L2. And I put my frequencies in L3. So the mean score is 3.2. What else are we looking for? The median aptitude, what's the median? 3. And what's the mode? The mode would be 2 because it has the largest frequency. So let's go put that back into our exam. Okay, so we had a mean of what, 3.2? And that was just calculated using my calculator. The median, again, was calculated using my calculator, which was what, 3? Now the mode is the data value with the largest frequency. So since the largest frequency is 5, the aptitude score of 2 is the mode. 2 occurs most often.
Why did it say please separate your answer?
You could actually have a set of data where you would have the same frequency for 2 different data values. That would be bimodal, and you would list both of those data values. For example, if this were 5, then it would be 2, 3. You'd have 2 data values, 2 scores with that same mode. Good question, thank you. All right, another multiple choice. And again, your multiple choice on your exam may not be the same as these. So be aware, what are you interested in knowing? You're interested in knowing the definition of mutually exclusive and independent. So mutually exclusive, we've already talked about. Mutually exclusive means it can't happen at the same time, correct? Independent means one outcome is not affected by another outcome. So if I roll a die, that's independent because I roll that die the first time, I get a value. I roll it a second time, the second roll is no way, shape, or form affected by the first roll. If I take a deck of cards and I pull out a card from a deck of cards, if I replace the card, then the second draw is no way, shape, or form affected by the first draw. If I don't replace it, it is. So with replacement is independent, without replacement is dependent. All right. So what's our question? You and a randomly selected student from your class both earn A's in this course. Is that mutually exclusive, neither, or independent? Independent, right? I would assume that your score in this course doesn't affect his score in this course unless you're study buddies. And then it could be, right? So what's the next one? You and your class partner both earn A's in this course. So is I mean, is it mutually exclusive? It's not, because you can both get A's. Is it independent? Maybe not. Are you studying together? So could your grade affect your study partners? So is it neither? And that is right there is what makes that dependent, is that you're affecting each other's grade because you're studying together. So that makes it dependent, not independent. If two events can occur at the same time, they must be independent. Did part B prove that to be incorrect? Because you can both get A's and it be dependent. So just because events are independent doesn't mean they can occur at the same time. Another example of this is rolling a die. So I roll a die twice and I get one on each roll. Those are still independent events, but I got a 1 on both of them. So this is, oh, I got that was a bad example, by the way. This is false. They can occur at the same time and still be dependent, because we just looked at the example above where you have a study partner, you both get A's, but that's not independent. It's not mutually exclusive and it's not independent. Okay, so it's not. It's not. All right. Suppose a basketball team had a season of games with the following characteristics. 60% of all the games were at-home games. Denote this by H. 25% of the games were wins, so we denote this using a W. 20% of all games were at-home wins. Out of the home games, we are interested in finding what proportion were wins. In order to figure this out, what do we need to find? What's that? I just need to know the nomenclature that for this.
Given that it's a home game, what's the chance that it wins? Which is like the last option.
So if you're only looking at games that are played at home and you're interested in the number of wins in the games that were played at home, you've reduced your sample space only to at-home games. So you want the number of wins given the game was played at home, which is the last option, as you said. Now, I don't guarantee that your problem will be identical, so maybe do a similar question to see if yours is identical. It may be, I don't remember. I'm always going to disclaimer that it may not be the same. So again, why is this this type of probability? Because you immediately reduced the sample space to only look at games that are at home. So this is a given. It's given that the games were played at home. And then what are you interested? The wins. 2 more questions. And if you get number 19 wrong, I'm going to come on your head. No, I really won't. We just recorded that, but I really won't do that. U and V are mutually exclusive. The probability of U is 0.17. The probability of event V is 0.56. What is the probability of U and V? If they are mutually exclusive, they can't occur at the same time. So the probability of an and, again, the app is trying to help me. Actually, if it does that weird streak of lines, it's static electricity with my Apple Pencil. I Googled it. All right, this will be 0. If your events are mutually exclusive, they can't occur at the same time. So an and probability would be 0. So what about the probability of U given V? Well, according to Bayes' theorem, this is the probability of U and V over the probability of V. So what is the probability of U given V? 0. Oh, by the way, the brain started working. This is a conditional probability. For some reason, I get so many C words in my head, conditional just. Okay, so then what's the probability of U or V? Well, according to our addition rule, U or V is the probability of V plus, or U, let's put U first. It doesn't really matter because we have U plus V, and then you subtract off the and, right? But I think we've established that's 0. So what's the probability of U or V? Do you just add them up? Is that 0.73? 0.56, 0.17, 3.73. Last but not least, woo! Another simple probability. And it does bold the instructions to use reduced fractions. So that gives me some guidance. A jar contains, oh, I like this problem. A jar contains 42 red marbles numbered 1 to 42 and 52 blue marbles numbered 1 to 52. The only difference in your problem on your test will be the number of marbles you have. It's still going to be odd, even, red, blue. A marble is drawn at random from the jar. Find the probability of the given event. The probability that the marble is red. How many marbles do I have? 94. So what's the probability that it's red? 42 out of 94. So if I reduce that, is that 21 over 47? I'm going to cancel or divide numerator and denominator by the number 2, which I can do. What's the probability that it's odd? If you got 94 numbers, how many of them are odd?
The other half.
The other half. Half of them. Half are even and half are odd. What's the probability the marble is red or odd? It is not the sum of those two. Why? Because you have to subtract off how many are red and odd. So again, our or probability is the probability that it's red, which we found, plus the probability that it's odd, which we found. But we have to subtract the probability that it's red and it's odd. How many are red and odd? Half of the 42? So 21 out of 94. And what do we have? I'm going to write these with the 94 because it'll be easier for me to do the subtraction. Plus 47 over 94. Half is 47 over 94. So what's that going to be? 42 plus 47 minus 21 over 94. So is that 89 minus 21? Is that 8? Is that 68? Did I do that correctly? Which is what, 34 over 47? If I divide the numerator and the denominator by 2. Okay, how about the last one, blue or even? So that's the probability that I draw a blue one out, plus the probability of drawing a odd number out, which is a half, minus that it's blue or odd, blue and odd, sorry. Okay, so what's the probability of being blue? 52 out of 94. What the odd, again, that's what, 47 out of 94, half of them are odd. And then how about blue and odd? Well, would that be the 21, excuse me, 26? 26 are blue and odd, 26 out of the 94. And my handy dandy calculator says that's 73 out of 94. So I don't need to reduce that fraction. Now, I know I'm done a little bit early, so I'm going to go do something on the calculator real quick. Your calculator does some things very well, and it will reduce fractions for you. So we had the 42 over 94. You can approach this a couple of different ways. You can certainly put 42 and divide it by 94. And it's going to give you a decimal. And then you can change that to a fraction. So in your math menu, number 1 is convert a decimal to a fraction. So 21 over 47. Or you can put it in as a fraction, and your fraction button is found in the y equals. So if I go alpha, y equals, number 1 is your fraction, numerator over denominator. And then I can just put the 42 in the top and the 94 in the bottom, and then hit enter. It's 21/47. So if you're nervous about reducing fractions, I would hope at this stage in your career, reducing fractions is second nature. But if you're nervous about it, you can use your calculator. Are there any questions? Bless you. Any questions? Well, you certainly can come see me or email me or call me, whatever you need to do between now and Tuesday. Tuesday morning, I will provide paper. You will need to bring a computer. Does everybody have a computer that they can use? If you don't, let me know and I'll just send you over to the testing center. That's not a big deal. Or I'll bring you a computer to use. I can do that too. That's probably easier to do. I'll provide you paper. You need your calculator. I do have 3 spare calculators in case yours decides that the battery wants to die mid-test. So you'll be okay there. You'll need something to write with. And you'll need to be sure that when you bring your cell phone into class, you take that cell phone out of your pocket, your purse, your backpack, and you put it face down on top of your desk. And that way I will know you're not using a cell phone to do your problems. All right, questions? All right, have a great weekend. We'll see you on Tuesday.